All right, so like I said, yesterday is pretty much exactly what we did today. We're going to look at a few things that are from a little bit different perspective. But I think a lot of it is going to make sense. Like I said, as long as you picked it up yesterday, it'll all kind of go smooth. So there's three columns that are on this sheet that we didn't do yesterday. So let's look at those three columns. The first thing is the first column on the far left. Can someone tell me what the name of this format is? It's called the nuclear symbol. So write that down. Nuclear. Okay. This is called the nuclear symbol. Now, you have some room kind of over there on the far left-hand side. I would like for you guys to write down, except the purple. We'll come back to that in a second. But you guys to write that down right there to the left of that. Okay. And this is going to kind of help you out. It's going to make a little bit of sense. So remember we have the AZX model, which is what I call it. So AZX, and what does A stand for? Mass number. A stands for mass number. And then Z stands for atomic number. We've already discussed this. It would be a whole lot easier if A was atomic number. I get it. Okay? But unfortunately, it doesn't always go the way we want it to go. So this is what we have to work with. So it's A over Z. Now, numerically wise, the value itself, which one is always the larger number, the top or the bottom? Top. Top number is always bigger. 0 for 2 today. Okay? So make sure that when you write this, you make sure the mass is always bigger than the atomic. Now, let me go ahead and throw you a curveball. Is it possible for those two numbers to be the same? Hint, hint, wink, wink. You may see it pop up. Okay? All right, so the next one. The second column has a name. Now, what format is that column written in? Very good. Hyphen notation. Okay? This is hyphen notation. Now, I need to say it. Again, I say some things just to make myself feel better a lot of the times, to know that I've told you. The value behind the hyphen is what number specifically? Mass number. Okay? I'll give you a bunt for that one. All right. So hyphen notation. So again, remember the value is the mass number. Our atomic number, that's kind of simple. What is the atomic number also representative of? The number of protons. So I'm going to come over here and I'm going to say this is also the atomic number. Sure, I love it. You can put Z if you want to. But let's go back to the atomic number for just a second. Where will you find the atomic number? Okay, on the PT. Now, you're right, it is in the top left corner of the periodic table, but just so we're all clear, is it always in the top left corner? No. Okay, so I want to make sure that it is on both of those, but over there on that one, it's in the top right-hand corner. So just know it's that whole number value. Is it on the top right up there too? Okay, I can't tell from this angle. Gotcha. Yeah, that one's on the left and the other two are on the top right. So again, just make sure it's that whole number value on the periodic table. All right, the mass number. Mathematically, how do you calculate the mass number? Very good. Protons plus the neutrons. Okay? Mass number is protons plus neutrons. All right? The charge. What two things do we compare when we're looking at the charge? Very good. We're comparing protons versus electrons. Now notice the difference between the previous one. The previous one says protons plus neutrons. That's math. You have to add them. But what do I mean when I say protons versus electrons? Perfect. So in a simplistic way of saying it, you're comparing the two. It's just a comparison of what do you have more of. Just real quick, again, saying this out loud. What happens if you have, what is it called if they have the same number of protons and neutrons? What do we call that? Neutral. And what's the value of a neutral charge? 0. Okay? All right. Now, this is the next column. I told you there was 3 columns that are a little different. Okay, go ahead and ask your question. Uh-huh. All right, well, how many electrons would you have? All right, so let's use your example. You said we have 2 protons and we have 1 electron. All right, what do you have more of? You have how many more? 1 more. All right, so if you've got 1 more proton, what's the sign of the proton? So it's 1 plus or plus 1, however you want to say it. That's the charge. Okay? All right, so this next column, I'm going to be honest with you, I think it's kind of a dumb column. However, it is what it is, and it's simple to do. But I think what they're trying to get you to understand is one of 2 things. Number 1, what 2 particles are in the nucleus? Very good. So it's the protons and the neutrons. I apologize about that color if you can barely see it, but I'm running out of colors. I'm trying to make them all different. So it's the protons and the neutrons. So there's 2 things they're trying to get you to see. Number 1, what other column is going to be identical to that value? Mass number. Okay. And it's a little and sign. Oh, it looks like a degree symbol. So let me go ahead and say this. What this little symbol is, so like N naught, that stands for naught, which basically means it's standard. And what standard means is neutral. That's where that little thing comes from. Okay? And also I use 0 for neutrality. It's not positive nor negative, it's neutral. Okay? All right. So what other column would be the exact same as the number of particles in the nucleus again? The mass number. So there's 2 things they're trying to get you to see. Number 1 is what 2 things are in the nucleus. Okay? And they're also trying to get you to see that what percent of the mass comes from the nucleus. 100%. The entire mass comes from the nucleus. So that's another thing they're trying to get you guys to see. All right, so the number of neutrons. What color have I not used yet? Orange. Okay, we can do orange. How do you find the number of neutrons? Symbolize it for me. A minus Z. Let me show you why you're going to like this worksheet. Okay, you just told me that the number of neutrons is A minus Z, which is, again, the mass number minus the number of what? Protons. Come over here to the far left column. Okay, do you agree that 23 is the mass number, which is what letter? A. 11 is the atomic number, which is also the number of protons, correct? So do you agree that you could do 23 minus 11? You can turn that into a very basic elementary subtraction problem. And that will give you the number of what? Neutrons. So what's 23 minus 11? Well, there's your number. Okay. So if you use this, it'll make it a whole lot easier to do it. Okay. And then last but not least is the number of electrons. Well, how are you going to know how many electrons you have? Very good. It depends on the charge. God bless. It depends on the charge. So here's what we're going to do. I'm going to do 3 examples with you guys, and then I'm going to give you a chance to do the rest of them on your own. The 3 that I'm going to do are the 3 that are very similar, yet they have some oddities about them. So the 3 that I'm going to do are these 3. Okay. Of those 3, which one, using that far, because that's the only thing we know is what's in that far left column in the nuclear symbol. Which one looks the weirdest and why? First one, second one, or third one? Why the third one? What do we call those things that have positive and negative charges on them? Very good. So this is the potassium ion. Okay, that is the potassium ion. Let me go ahead and tell you for the future. Do you see, and again, some of these in here, I'm going to go ahead and show you that one and that one. Those have charges. When you come over here to do the nuclear symbol, do you need to include that charge on the ion? Yes, make sure you include that over here in the follow on the far left column. Now, let's look at the other two. What is the only difference between the first one and the second one? The top number, which is also the mass number. What do we call things that are the same element with a different mass? Look at you. These are isotopes. Now, congratulations. You've all learned a fact. Isotopes are same elements, different masses. But specifically, what makes them have different masses? Number of neutrons. Because if you change the protons, what do you change? You change the element. If you change the electrons, you change that C word, the charge. If you change the neutrons, you change that M word, the mass. Okay, so that's how we can all relate those things. All right, now let's go ahead and let's look at the hyphen notation. What is the element that we're dealing with here? All three of them are potassium. So go ahead and write potassium on all three of them. Now, these are all hyphen notations. And again, one more time to make myself feel better, what is the value that goes behind the hyphen? The mass number. So what is the mass number for the first one? 39. And what about the last two? 41 and 41. Very good. So that is going to be your hyphen notation. Any questions on that? All right, let's go to the next column. Atomic number. How can you find the atomic number? Where is it? It's on the periodic table. What is the atomic number for potassium? Very good. 19, 19, and 19. Is there anything that we've already written that will tell us the mass number? There's two places, right? When you're looking at your AZX model, which number is it, the top or the bottom? Top, very good. And also in the hyphen notation, it's the value written. So what's the mass number for the top one? 39. And then what about the bottom two? 41. Now, not all of them are going to be this easy. These are just the three that are very similar. All right. Now, we've already talked about this. The charge. Which one has a charge, and how do you know? The bottom one, because it has a what? It's got that +1 right here, which tells me the charge is what? +1. Hold that thought. Okay. Now, because the other two do not have a positive or negative, what do we assume about them? They're neutral. And what's the value for neutral? 0. Fantastic. Now, I put slashes through my zeros just to make them more emphatic. Okay. All right, the next column, the particles in the nucleus. Again, this is kind of a silly column, but it is what it is. What other columns should it match exactly? The mass number. So we can go ahead and transfer those numbers. So we've got 39 on the top one and 41 in the bottom two. Okay. All right, so let's look at the number of protons. What column should the number of protons automatically match? The atomic number. And what should all three of them be? 19. Very good. Again, if you change the number of protons, what do you change? You change the whole element. Okay. Now, the tough one. But again, if you use the nuclear symbol, it's going to make the math really, really easy. How do you determine the number of neutrons? Okay, the top minus the bottom, A minus Z, or the mass number minus the atomic number. So what is, in the top one, what is 39 minus 19? 20. Very good. All right, well, the other two are going to be identical. What is 41 minus 19? Very good. 22. All right, and last but not least is the number of electrons. And up there in the very top, we said the number of electrons depends on what thing? The charge. Everybody with me? Okay. So, the ones that are neutral, which are the first two, since it's neutral, how do the electrons and the protons compare? They're the same. Well, how many protons do you have in the first two? 19, so that means you have how many electrons? 19 each. Right, here's the last one. What is the charge on the third one? The charge is 1 plus, which means you have one more what? Proton, because it's what charge? Positive charge. Well, if you've got 19 protons and you've got one more proton, so how many electrons should you have? 18. Fantastic. Any questions on that? Any questions at all? Go ahead. You have to be able to figure it out based on the proton versus electron comparison. Does that make sense? So, like, imagine we didn't know that it was a +1 charge. That's actually a really good question from this point. And all you had was that number and that number. That's all you saw. Could you still tell me my charge? Okay. What do you have more of? So is that a positive or a negative charge? All right. How many more do you have? So that's why it's a 1 plus. Does that make sense? Okay. Right here, let's do one more. I'm going to do one more row together, but I want to do one more charge for you, okay? Everyone look at this one right here and right here. So we're comparing protons and we're comparing electrons, okay? So my question to you is, what do you have more of? How many more electrons? 3. So the charge is 3, and what's your sign? Very good. So over here you can come in and you can put 3 negative as your charge. Does everyone understand why it's negative? Everybody good on that? All right. I want to do one more with you guys, and that's because second period when they did it, they were like, I don't understand any of this. And it's the hardest one on here, so let me do it with you. It's the one that's the third from the bottom, and it says the charge is +1, and the number of particles in the nucleus is 1. Does everybody find that right? All right. So the only thing we know is the charge is 1 positive, which means you have one more what? One more proton. We don't know how many we have yet, but we at least have to have one more proton. And we know that there's how many things in the nucleus? 1. All right, well, what are the 2 things in the nucleus? Protons and neutrons. We only have one thing in there. So, what can it only be if there's only one thing? Proton or neutron? It has to be a proton. If you do not have a proton, is it an atom? No, because all those numbers up there represent the number of protons. So if you know that it's one thing in the nucleus, what does it have to be? It's got to be a proton. So I know a lot of you have already figured this out, but I want to stay on the same page and making sure that we're all kind of following the mental process here. So if we have one proton, then how many neutrons can we have? 0. We can't have any. Well, if we know that there's one proton, then what is the atomic number? 1. Well, now let's think about it. Who is number 1? Hydrogen. Very good. So I'm going to write H here. I'm going to write H. I'm going to go ahead and write hydrogen. And I'm kind of maybe doing this in a long, roundabout way, and you may have already figured it out, but I'm just kind of talking it out loud. All right, so let's go back to our charge. Well, if you've got one proton, and the charge is 1 positive, then how many electrons can you have? None. You can't have any. And I know that sounds really, really, really weird. So what is the only thing in this atom? A proton. So it's literally a proton just floating around in air, which is what? Protium. This is protium. I know that makes absolutely no sense. But what it technically is the protium ion. And how do you know it's an ion? It's charged. Okay? So what has happened is something has zinged by protium and snatched this electron away from it. Okay? All right, now let's go back and let's finish this up. What is the... Go ahead. That's what I was getting to next. So if it's got one proton and no neutrons, what's its mass number? 1. Very good. All right, well, what's the value then going to go after the hydrogen and the hyphen? 1. And this is where it gets really weird. What's the mass number? 1. What's the atomic number? So it's 1/1. Is there a charge on this thing? What is the charge? So it's 1/1 H plus. I know it looks weird, and I know it looks strange, but it is real. Okay? Alright, so your objective is to see if you can do the rest of these grids and the questions at the bottom. I'm going to go ahead and tell you, those questions at the bottom are challenging. If you can figure all those out down here, you got it. I have no worries about you at all. So I want to make sure that you can do all of it. Okay, so you got the rest of the class to do it. Yep, and I'm going to walk around and help you answer any questions that you guys have.